So the event sourcing pattern is a well-known pattern, has been around for quite some time. And this combines well with the materialized view pattern, as well as the CQRS patterns. These are all very common in event-driven architectures, but what are they? Well, join me and Steph as we talk about these patterns in more detail today on Cloud with Chris. Hello and welcome back to another episode of Cloud with Chris. You're with me, Chris Reddington, and we will be talking about all things cloud. Now, as we mentioned in the intro there, we are joined once again by Steph, and we're going to be talking about 3 patterns today, so lots of content to drive straight into here. So at this point, all there is for me to do is introduce Steph once again. So hello, Steph. How are you doing?
Hey, Chris. Yeah, good to be back. I'm fine, thank you. How are you?
All good, thank you. All good. Glad to have you back as well. I think the last one that we did, which feels like a lifetime ago already, was a very good session, and glad to have you back talking about 3 today. So we got a lot of ground to cover. So I guess then we talked in the intro there about event sourcing, materialized view, and CQRS. Lots of different patterns that we're talking about, lots of words for people to digest there. So where should we start? Where do you think makes sense?
Let's start with event sourcing.
Okay, cool. So I guess then event sourcing is something that at least I'm aware of has been around for quite some time, and people listening in might be thinking, hold on, I thought we're talking about cloud patterns, and cloud patterns are the new and shiny kind of patterns. So is event sourcing anything new? Is it the same thing we knew? And maybe let's kick off from there.
Yeah, so it's the same pattern that's been around, but it's absolutely applicable to the cloud, and arguably more useful in the cloud now than we've ever seen on premises. Sure. or in other environments previously. So this basically is we're less interested in the end result than we are in your journey to get there. So if I was to say to you, what did you do today, Chris? And you said, I went to the supermarket and I spent X amount of money on my Christmas groceries. Mm. That's great. That tells me how much you've spent. I might get some itemized view of what you've bought and what time you went and how long it took you. What it doesn't tell me is that you walked into the vegetable aisle and you picked up your Brussels sprouts, and then you picked up your parsnips, and then you picked up some carrots and decided, actually, no, you've already got some of those, so you put those back. And all of those events and all of those decision points that you make when you're shopping are something that is recorded in the event sourcing pattern. Gotcha. So not so much, hopefully we don't have people spying on us on the supermarket aisles, but if you translate that and you decided to buy your Brussels sprouts online, or Brussels sprouts chocolates online you can buy, then we'd be interested in seeing that you've added something to your basket, and also that you've taken something out of your basket. Gotcha. So we're recording every event. We're recording potentially your journey through our website. So how you're navigating. Have you picked up an item in your basket on the basis of a recommendation from something else that you've just picked up? And then what you've decided not to buy, and using that kind of pattern, we can then start sending things like targeted emails to say, well, we see that you had this in your basket and you decided not to buy it. Perhaps it's something that you might want to consider buying in the future. And we can start to try and identify behaviors of users, or website users, customers, and that kind of thing. So it's a really interesting pattern for companies trying to get ahead in the marketplace to understand their customers' behaviors. Gotcha. Makes complete sense. And I think, just to assure viewers as well, I will not be buying my Brussels sprouts. I'm not a Brussels sprouts fan, I'll admit, but Brussels sprouts chocolates sounds intriguing. I think I'll pass on that one for now. But getting back to event sourcing, it makes complete sense. I think, when we think about this world that we're living in cloud, where we see a lot more people really focusing on the data and the insights that they can generate. I think if you were going for this more kind of typical end result where you just saw the fact that, hey, Chris's shopping was this much, there's a lot of insight you're probably not gaining, as you say, that I put this in my basket, I removed this from my basket. And
all of that insight doesn't necessarily get used in the end results, which I guess is the next pattern we'll talk about. So I won't go to that one just yet. But it really gives us that log, I guess, of, this activity happened, this activity happened, this activity happened, and you can play all those back. So if, something really bad happened, for example, or you need to understand the state of a system at a certain point of time. I guess financial systems are very common for this type of scenario. You can, I guess, play those events back as well. So you can go, right, at this stage, we know that this was the state in the system. Fast forward, it was here. What happened in between to cause, state and effect kind of scenario there? So it seems like quite a powerful pattern then.
Yeah, absolutely. There is a number of use cases. And as you've said, the financial one is another one. So say I was feeling particularly generous because it's Christmas and I'm going to transfer you some money. The activities that might happen there would be my account would be checked. So my name and my account number match. Your account would be checked, the same thing. We might do some fraud checking. We'd need to do some balance checking to make sure I've actually got the money that I can send to you for your Christmas gift. Otherwise, it's not very nice. But there's a lot of fraud checking then that goes on, and lots of other processes as well. And banks typically don't necessarily do most of this themselves. They will have a common platform that does all of this kind of checking. And that's why in the old days, bank transfers or transferring money used to take 3 days to clear. Yeah. So I would say to you, I've transferred it and it would take 3 days to get there because there's quite a lot of to and fro. With this pattern, we can record all of those steps. We could queue things as well. So using queuing to have activities run off as triggered off certain events. And when the financial services come knocking and say this looked like a fraudulent activity, we can go back and, as you say, replay all of the events to make sure that things were done in the right way.
Sure. And I think there was something that you touched upon there that's equally valuable as well, which is this idea that you're not necessarily going to have this big monolith doing absolutely everything, because these are events. And I hinted at it a little bit earlier that these event-driven architectures will commonly use patterns like this event sourcing. Clues in the name, I guess. There we go. But this idea that, hey, we've got an event that a transfer has happened. We might have a microservice, for example, which is listening for events of transactions. And it's just going to go ahead and check, is that fraudulent? Is there anything which looks a bit suspicious around it? There might be then some decorator pattern that goes ahead and makes transactions look really nice in the UI for some reason, or whatever scenario you want to apply to it. And I think you made a really good point there that we were used to having 3 days. Yes, eventually things will catch up and all the systems will replicate and we finally see the data there that I've got my amount of money. Great. But I think when you look at some of the modern banks these days, and let's think of some examples like Starling or Revolut or Monzo, where you can get notifications like that, it's forcing a lot of these industries to really go and look at how they can be a bit more clever with the types of data they have and how they go and use that data as well. So for anyone listening who's thinking where this pattern can be used, I think that's a really great example of how it can really change and impact something that we take for granted, really.
Yeah, absolutely.
Good. So I guess then that's where it works. That's kind of the scenario where it really shines, I guess. We talked about those retail scenarios, the finance scenarios, but I'm going to make an assumption here that it's not always going to fit our scenario, I'm guessing.
Yeah, absolutely. It's a very, very specific type of data that we're capturing with this, with the very specific purpose. When we come to want to know actually how much did you spend and what did you buy, it's really hard to report on that kind of data stored.
Sure.
Because it's very granular. We don't even necessarily have events in the right order because, as you said, if things are being triggered or we're using microservices, we might receive the events out of order. So it's really hard to report on because you have to try and get things in the right place. And there's also some other things you need to be a little bit aware of as well. If you're triggering activities off it, such as stock control. I know you're not going to buy the sprouts, but somebody will. And say buying those sprouts triggered an event that said, "Oh, we need to restock because we're running low on sprouts." And we don't trigger. We trigger that after you've done the delete or after you've removed it from your basket. If they've come out of sync, then actually we're going to end up with more sprouts than we need.
We definitely don't want that.
Or even worse, you might get to the checkout and find that actually the sprouts are no longer available.
I'd be okay with that, but I get others might not be.
So you have to be a little bit careful with what order things arrive in, and understand what it is that you're actually wanting to do with the data.
Yep. Makes sense.
Because you could get yourself in a bit of a mess. And then, as I said, actually reporting on the end of it, what was the end output of that? Because we still want to know that as well. We still do want to know how much you spent. This isn't an easy set of data to report on.
Sure. And I guess even, I guess the scenario there we've been thinking about is me, Chris, how much I've spent and, the things that are in my basket. But if we imagine we've got a shop or a store of 100 people shopping online right now at one point, and I wanted to see the spend, for example, over an hour or over a series of hours, certain product ranges, etc., and we start prioritizing what we need to order, what we need to prioritize and put offers on, that's going to be really complex and just not an easy problem to go and solve and bring that together, right? And I guess that's the other angle that we're really thinking about there as well.
Yeah, absolutely. And typically those types of analytical queries are not written by people who are highly technical, should we say?
Right.
Report writers, very very good skill to have, but don't necessarily and don't need to understand the underlying platform, whether that's a SQL store or a Cosmos store or no SQL store, whatever it might be. They don't need to understand how the platform works. And so if they then start to try to write queries on that against that platform, you're going to get some performance problems. You've potentially got bad data coming out, because if you haven't understood how the data is recorded in the first place, then you might assume that just because you had something in the basket, you bought it, whereas actually you need to take into account that it was removed later. So you could get in a real mess with trying to report on what is the end outcome from something like this.
Gotcha. And there's a really good point in there as well, actually, that I guess with my background, I hadn't really appreciated around the report side of things, where, to be frank, those report writers, they don't really need to have an appreciation of what's under the covers, right? They don't care, quite frankly, as you say. I think it's like a similar idea from an application design perspective, that we want to decouple certain components. So, the data's there under the covers. Maybe the data team go and completely pull apart whatever actual data backend is being used. But from your report perspective, you just keep on using whatever tool you're using. You don't care what's behind the curtain, and you don't care what's there. So that makes sense. And I guess that is then what takes us on to that next pattern, if I'm reading into that rightly.
Absolutely, yeah. So the materialized view pattern. So this really is making things easier for end users to report on data that is not necessarily conducive to having reports written about it. So the types of things like the event sourcing data definitely qualifies here. So this gives you the ability to create a physical store of the data in a format that is useful for end users. So I come from a SQL background. We have views in SQL. We have indexed views in SQL, and a view is just a query over the data, the tables and the columns that is written by somebody who understands the platform and understands how the data is coming in, how it works, when it's ready to be used in a view or in a report, I should say. And then the report user can just look at that view. A materialized view is a physical store. So unlike a standard view in SQL, which is just the query, this actually stores the data. So again, you're minimizing any impact on the underlying data store, because it doesn't matter how many times you go and query it, it's got that data already stored in the view ready for you to use.
Gotcha.
Has other advantages as well. So you could use this for security purposes. So maybe we don't want end users to be able to see all of the data. Certainly we shouldn't be letting them see PII data, for example, or anything that's sensitive. So they just need to know. They don't need to know your name. They just need to know somebody bought something at this value. So it's really good for that as well. And this can be, I use SQL as an example. We'd have an indexed view in SQL for this purpose, but this really is just a view, a copy of the data in a reportable format, and the underlying data that it's reading from could be anything.
It's interesting because what you've explained there, I was thinking to some scenarios that I've worked in as well, and I've mentioned on the show previously for anyone listening in, a pet project that I've had around Yu-Gi-Oh cards and collecting those. And one of the things that I built was processor building. Like many side projects, it's collecting dust at the moment, but building is like an inventory system, so a multi-tenanted inventory system, like a software as a service. Anyone could go and log their inventories in there, and it's kind of similar. I kind of might be broadly mapping things here, but stick with me, is as I'm logging cards into an inventory, that's a bit like events. Those cards are individual items, but then what I'm doing is I want to understand across my entire collection, hey, how many cards have I got of this type, of this rarity, of this thing, etc., etc. So the way that I'm doing that is actually not through SQL. I've given the game away there. It's through Cosmos, and I'm actually using the eventing capabilities inside of Cosmos to help me generate some of those views. So the view that I have is just another database inside of Cosmos then. So just in case anyone's listening in thinking, okay, I've heard of materialized views, I've heard them in SQL. We're not just limited to the technology. Again, this is an architectural pattern, right, that you could apply in many different scenarios, not just one technology here.
Dare I mention Excel? You could do it in there too.
I mean, if we're going to mention that, we should mention Access, because Access is a database after all, right? For anyone listening in, that's a little dig and sarcasm. So we're going to move swiftly on before I offend any guests. But yeah, coming back to the point around Cosmos, I think that's just another example of where I've personally used Materialized View. And I guess, putting myself on a limb here, you wouldn't have to necessarily use the same technology either, right? Because you could go and mix and match.
Absolutely. And it's really good if you needed to combine data from different stores as well. So say you've got data in Cosmos and you've got data in SQL and you've got data in something like a data lake. And actually, I think probably the most common place you'd see the materialized view would be Power BI. Essentially, if you're importing a model, you are writing your queries against your data stores. The end user doesn't care where that data is coming from. It could be coming from SQL. It could be coming from data lake. It could be coming from other relational data stores. Or anywhere really, flat files, CSV, you name it. And essentially you're presenting a model that the data is then available for users to go and query. You'd have different tables, so they would be your different views essentially. And the end users can go and slice and dice on that data to their heart's content, never having to touch the underlying store, never having to care about it. The data is physically stored in Power BI for them. Gotcha.
What's got me thinking there, though, is something you just mentioned about the user won't have to go back. The user won't have to go to the underlying data store. But I guess whatever technology, and we'll keep it abstract for now, but you've obviously got some kind of materialized view and some kind of back end that the materialized view is pulling from. We're going to be limited, I guess, to how often that's going to be synchronizing or pulling that data as well. And that's maybe a challenge with this pattern, is what I'm guessing here.
It is, yeah. There is definitely some overhead. I mean, different technologies will have different ways of doing it, and it depends how many different sources you're mixing. If you're just going with SQL, then it will automatically update that view for you. bear in mind there's going to be an extra write overhead whilst you're, on your platform whilst it's doing that. Other platforms don't have it, so you would have to decide, how often do I need this updated? How much resource is it going to take to keep it updated? And with something like Power BI, you might find that happens overnight, and that's fine. So we just refresh it overnight. Some more and more, actually, we're seeing people want things in what we describe as real time, or near real time. Yep. And so there is that pressure to keep this data up to date, keep these materialized views as up to date as we can, whilst minimizing the overhead, both against the source systems, but also, anything that's doing the integration, any code that's running, people that have to maintain it. If the data is particularly changeable, if you want to add a new record type or a new column or something like that, do we have to go and rewrite the materialized views? And whilst they are very easy to update, in theory, it's still, if it's a frequently changing data set, you still have to have somebody that's going to be available to do that.
Yeah.
So we're talking resource in terms of technology resource, but also people resource.
No, makes sense. And I guess that is a challenge, especially the fact that, just coming back onto the real-time point, I think there's always this grayness, let's say, around what real time means. It's such an ambiguous term, because real time for me might be, as long as I get it in the next 2 or 3 hours, I'm absolutely fine. Whereas for, a stock market or trading kind of platform, real time is quite literally the milliseconds, and obviously very different scenarios there. But it's just interesting, again, bringing it back onto that favorite word of ours on this show, requirements, just understanding the nuances of some of those considerations is really important, because that would have a huge effect on things like scale, how you architect, the underlying technologies there as well. Interesting.
Yeah, and you're right, and it comes down to communication, because if you ask a report user, how up to date does this data need to be, they will always say real time.
Yep.
And their definition of real time, as you say, it might be 2 to 3 hours. But if they say real time to the technical team will try to solve something as real time, how they understand it, which might be milliseconds. Yep. So it's really important to get the requirements of how up to date does this data need to be realistically, and make sure that everybody understands that whatever terminology you use for it, that you're all interpreting it the same way, because otherwise this pattern has the potential to cause massive overhead.
Yeah, gotcha. And just as a side point here, that is something that always amuses me when we talk about things like requirements, is how you can all be speaking a common language, but yet be speaking a completely different language at the same time. Trying to get that extra set of information is always a bit of an art form and a skill that I think is really useful for architects. So anyone listening in, just to always keep that in the back of your mind is what I would say there. Cool. So then I guess I can kind of see where we're going with the next pattern then as well, because we've talked about the fact that if you're generating your views, for example, that's going to cause some extra overhead on the underlying platform that you're talking about. So CQRS, just a load of letters, I guess, for anyone listening in.
It is a load of letters.
So CQRS, what is it, and how does it relate to what we've talked about so far then?
So we can't get away without using at least a couple of acronyms in a session like this.
Absolutely.
So CQRS, Command and Query Responsibility Segregation, which I appreciate is a bit of a mouthful, and I can see why CQRS is a lot easier to say and to remember. But this basically is separating out your reads from your writes. So we've talked about requirements, we've talked about real time, we've talked about I want my data, all of it, and I want it now. When you're trying to run queries that get you that data on platforms that are extremely write intensive, so OLTP system, online transactional processing, anything that's happening through a website, if you're capturing web traffic and you're capturing writes, you've got a contention for resource. There's only so much underlying compute and memory in whatever platform it is you have provisioned, whether that's a PaaS platform or an IaaS platform. You provision a certain amount of resource for that to use. There will always be contention, and you can't you can't optimize for both reads and writes on the same platform. You can have a compromise, and a lot of platforms and a lot of customers don't have a problem with having read workloads on their main data stores. But I think in the data world, we definitely see this a lot in terms of reporting. So where we have to do complex queries on data, where we have to be joining data, perhaps enriching it from other sources, it's let's hive all of that data off in its raw state, put it somewhere else, and then let's use that as our read platform, so that our writes can quite happily use all of the resources to keep our data inserting and updating or deleting or whatever it might be. And then we can use a separate copy of that data for our read workload.
Makes sense. And I'm going to also take it back to the example I gave earlier with the Yu-Gi-Oh cards kind of inventory system that I mentioned. And I mentioned earlier, it's Cosmos DB that's under the covers there. And I think this pattern also maps really well to something like that. And the reason I say that is if you think about Cosmos DB, and for anyone listening in who hasn't used it before, Cosmos DB is a NoSQL store. So very different to something like SQL or your traditional relational database. But the way the access patterns work inside of Cosmos DB, you're kind of penalized if you're not making your queries efficient, and both in terms of directly relating to cost and performance, because the way that cost is handled inside of Cosmos DB is like throughput. So the worse performing your queries are, the worse throughput you're going to get. So the more you can optimize those access approaches for your database, the better. And I think it's exactly the same there, because if we want to do reads, then let's optimize the store for reads. If we want to do writes, let's optimize the store for writes. And they're going to be slightly different depending upon what we want to do there as well.
Absolutely. And Cosmos is a really good example, actually, because when you partition the data, you want to partition it so that you are writing to all of your partitions at the same time, so that you're making the best use of your throughput. But when you're reading, you want to be looking at a single partition, because cross-partition queries will hurt you. So your patterns are really important, and something like the Cosmos change feed is really useful there to provide you with a copy of your data in a slightly different format that you can then do something else with. So you, in this case, you'd be reading it.
Yeah, makes sense. Makes complete sense. So I guess then we've got 3 patterns so far. We've got event sourcing, we've got materialized view, and we've got CQRS. And I think it's clear how all of those build onto each other there. Do we always have to use all of them together, though? I guess probably not, would be my gut.
Absolutely not. I think definitely if you're using the event sourcing pattern, then you definitely need something else. Materialized view or CQRS, anything that's going to be taking that raw data and putting it into a format that is somewhere else in a format that is readable. Then I think it's definitely, you need one of those two for event sourcing. Materialized view itself, I mean, it has definite advantages with some of those other patterns, but it also has disadvantages. If you've got quite a simple data store and you don't have any need to store a separate copy of that data, then don't use the materialized view.
Sure.
You could use standard views in SQL. You can control access via permissions and things like that, so that people can only see what they're supposed to see. And it reduces the overhead of maintaining that and also writing it and storing it. So you're paying for storing the data twice. And we say storage is cheap, and it is to a point. But if you're storing terabytes of data and you're storing that twice, it's going to add up. So the materialized view definitely has its place, and CQRS likewise as well. I mean, if you haven't got resource contention, don't go and spin up another service just so that you can use CQRS and double your costs for the sake of it. So they have their place, and event sourcing obviously is a very specific type of data you're trying to capture. So don't use that for most of your queries, most of your data sets, unless you're specifically after capturing that very granular journey process.
Sure, makes sense. And actually, there was there was a word that kind of triggered a thought process with me a moment ago, and you mentioned about resource contention. And I guess actually, I think from that perspective, we were talking about the cloud services from a resource perspective there. But I think with this, and maybe I'm thinking a bit ahead here, but there's also the resources of the team that are building this thing as well. And
absolutely,
if I'm reading this in my kind of app dev hat now, because that's my background, obviously, and what I'm thinking about is, I would have some APIs that are going to go and access some data stores, for example. For me, it's fairly easy to go ahead and just put some kind of facade in front of those that I can point to whatever data store. I can make that nice and easily to switch over. But if I'm reading into this and this kind of CQRS pattern and balancing that out, that could potentially be a lot of extra work, is what I'm thinking from if you're a small team and you're just trying to deliver a core data platform, for example, I can imagine that could add quite a bit of overhead. Yeah,
it could do. And especially, I come from a data background as an accidental DBA, and the more systems that are live that could wake me up at 3:00 in the morning because something's gone wrong, the worse it's going to be for me and my team. Yeah. So yes, you have got to consider the people aspect of it as well as the compute and memory aspect of it.
Yeah.
Don't just throw darts at the pattern dartboard and pick one that feels like it would be fun to try. All of these patterns are really interesting and really good to investigate, but they have their use cases, and if your use case doesn't match the pattern, don't use it.
Yeah. Couldn't say it better myself. And I think, just to echo something you said earlier, which was around the complexity of adopting these patterns, I think every time you take on a pattern, there is always going to be a trade-off. Patterns have their places, and yes, you can use them. They solve specific problems, but that's exactly the point, isn't it? They solve specific problems, and something like Materialized View or something like CQRS, or even event sourcing, I guess we could argue as well, all solve a specific purpose. But if you don't have that challenge in your environment, are you just creating more complexity for the sake of creating more complexity? And I'm going to bring it back to our favorite word again, requirements. You knew where I was going. It always needs to be based around that, doesn't it? Because you could always architect the theoretical perfect system because you've used all of the patterns, but real world operating it, it's just, like you say, such a challenge. And I was smiling when you said accidental DBA, because in my head, I had a DBA who was doing some kind of delete from star type scenario, and that's what I thought of accidental DBA. But we'll go past that. But no, I think there's a real risk, right, where we're showing all these patterns, and people go, "Oh, okay, let's go and adopt this pattern or this pattern and do this thing because it sounds really cool." I think the flip side to it is just make sure you know the problems you're trying to solve and why you're trying to solve them.
Absolutely. And don't just assume that a pattern that you've used previously will work for your next project either, because again, requirements, what you're trying to solve might be different. I do have a little funny story from a friend of mine that I used to work with years ago. And when he was courting his now wife, he was invited around for dinner, and his wife took a joint of beef and cut both ends off, put it in the pan and roasted it. Mm-hmm. And he said, "Why did you do that?" And she said, "Well, we've always done it like that." And so when he was then privileged enough to meet his future mother-in-law, he asked her, "Why do you do that, cutting the ends off the meat before you put it in the pan?" And she said, "Because the pan wasn't big enough." And I just think that is such a good analogy for actually how people do fall into that pattern trap of, I've used this before, therefore it must be right. And yes, it probably was right at the time, but not necessarily for your new circumstance.
Absolutely. And there's workarounds, right? Like get a bigger pan.
Exactly.
There's always another way of looking at it. So I love that. That's a great analogy.
Bring it back full circle. If you get a bigger pan, you can put your sprouts in there as well.
Oh, I don't know about that. I think that's time for us to close out here. So Steph, a nice segue, nice transition there. I guess we covered 3 patterns there. Another really great session there, so thank you for joining. I guess any final remarks, final thoughts that you want to leave people with here, because we've covered a lot of ground there. Is there anything that particularly stands out for you that you think people need to take away here?
I think whatever pattern you're going to use, just be clear on what it is you're trying to solve. Certainly the last 2 patterns that we've looked at have their place, but also have their pitfalls. So yeah, and have a look at event sourcing for that kind of traffic. If you're in the worlds that of online retailing, for example, that could be something that's really interesting and provide you some additional insights on your data that you don't currently have.
Excellent. Well, another great session there, Steph. So thank you very much for joining. Really, really appreciate it. And all there is to say is wish you a very Merry Christmas over the coming weeks.
And you too.
Thank you, Steph. So, another great session. 3 different patterns that we focused on there. So, event sourcing, that well-known pattern. Materialized view, again, quite a well-known pattern. You may have heard it in other technologies already. And CQRS as well. And really the thing we should reiterate is there's not always a need to use those patterns. You really need to look at the challenges you're trying to solve, what your requirements are, and whether those patterns fit there, because there is a risk that you introduce more complexity for the sake of introducing it there. But hopefully that clears up where and when you might use those patterns and the values they can bring. So another great session there in the architecting for the cloud, 1 pattern at a time, and once again joined by Steph, who has done a great job there talking through those patterns. So thank you for joining us. You know what to do. Please like, please subscribe, please follow, and please share to others who you think might benefit from that content as well. So in the meantime, thank you for watching, and until next time, bye for now.